Good evening, guys. So, as you all know, today we are going to discuss about VCRS, that is vapor compression and refrigeration cycle. So, first, let us discuss about the components of VCRS. Okay. So, yeah, the components of VCRS are compressor, condenser, dryer, thermostatic expansion valve, evaporator, sensing bulb, and capillary tube. Right. So, as Gaurav was saying, the high pressure cutout and low pressure cutout, yeah, those are also the components, but those are actually the safety components, right? Those are the safeties of refrigeration, correct?
Right.
Yeah, okay. So, first, let us discuss about the components one by one. So, what is the working, what is the function of compressor, guys? Why compressor is used?
To increase the pressure and temperature of the refrigerant.
Okay, to increase the pressure and temperature. How?
Uh, we compress the saturated vapor refrigerant into the compressor
Yeah.
centrifugally. So here temperature of the refrigerant increases, also pressure increases up to 10 bar.
Okay. So actually today we are not going to discuss about the pressure and temperature at particular components like what is the pressure and temperature at condenser and what is the pressure and temperature at compressor. So today we are just discussing about the basics of VCRS. So we are going to understand what is VCRS first. And later on we'll speak about what is the temperature, what is the pressure, and what is high pressure cutout and all the safeties. So we'll discuss it later. So first we will discuss the working principle and how does VCR cycle work. Okay. Is it clear, guys?
Yes.
Yeah. Okay. So let us begin with the VCRS. So so basically the VCRS cycle is divided into four stages. Okay. So can anyone say what are the four stages of VCRS cycle?
I know about two stages: high pressure stage and low pressure stage.
Sorry.
High pressure and low pressure.
Okay. High pressure stage and low pressure stage. No, that is not the right answer actually.
Bro,
So,
can I uh,
uh,
uh, Raviraj, the two type of states that are you saying that is uh, VCRS is totally convert. You divided VCRS into two parts like low
Yes,
pressure
yes,
side and high pressure side.
yes, yes,
That is
right.
not the stages of working principle of VCRS cycle. VCRS cycle working principle uh, parts are compression processor, condensation process, expansion throttling process, and the last stage is evaporating process.
Okay, okay, I got it.
yeah, yeah, that's actually correct. So, if we go technically, so first is isentropic compression. Okay. So, isentropic compression. What do you mean by isentropic compression, guys?
It means here heat is not reject or it is not absorbed. I think.
Okay. So, actually, the first let me discuss about the four stages and let us discuss one by one what are those stages. Okay. So the first stage is isentropic compression using compressor. Okay, isentropic compression happens in compressor, right? It doesn't happen in condenser, right? So the
Right.
first stage is isentropic compression, and the second stage is isobaric condensation. Okay, isobaric condensation or isobaric heat rejection, both are same because heat rejection and condensation both are same. So that's why the second process is isobaric condensation or isobaric heat rejection. Okay. So the third stage is isenthalpic expansion using thermostatic expansion valve. Okay, isenthalpic expansion. And the fourth process is isobaric heat absorption or evaporation using evaporator. Isobaric evaporation or isobaric heat absorption. Okay, so these are the four stages of VCRS. So just let me show. I have written the notes. Just a second, guys. I will share. Is this visible, guys? Hello? Yeah, okay. You guys can see here, I have written down all the four stages of VCRS. That is isentropic compression using, actually that is compressor, guys. Note it as a compressor. I have by mistake written it as a condenser. So second one is isobaric condensation or isobaric heat rejection. And third one is isenthalpic expansion using thermostatic expansion one. And fourth one is isobaric heat absorption or evaporation using evaporator. Okay. So, to understand all the four stages, we need to understand the graph first. Okay. So, guys, is this graph visible to you?
Yes.
Yeah. This is okay. So as you can see here in graph, so actually in VCRS we get two graphs. Okay. So I will just share all the photo of two graphs. So here it is. Yeah. Do you guys having an option to zoom this?
Yes, bro.
Yeah. Okay. So here are the two graphs. Are both graphs visible to you?
Yeah, yeah.
Yeah, okay. So the first one is temperature versus enthalpy graph, and second one is pressure versus the first one is temperature versus entropy, and the second one is pressure versus enthalpy. Okay. So let us understand it one by one. Okay. So all the four stages which I have said is explained clearly in this graph. Okay. So what happens is in VCRS cycle, when we look back into the diagram. So, first the low pressure and low temperature vapor refrigerant enters into the compressor, right? So, after entering into the compressor is compressing the refrigerant. That is vapor refrigerant, okay? That is fully vapor refrigerant, superheated refrigerant it is, okay? So, that superheated refrigerant is compressed and passed to the condenser. So, when at the discharge side of the compressor, the low pressure, low temperature, superheated uh, vapor refrigerant is converted into high pressure, high temperature, superheated vapor refrigerant. Okay, because it is compressed. So if I represent it in a graph, it is like this. You can see 1 to 2. Okay, it is compressor. It is compression. Okay, so in compression, you guys can see that T1 to T2, that is temperature is increasing. Okay, whereas the enthalpy is constant. Entropy is constant. Okay, so can you guys see this? 1 to 2 in the first graph. Just a second. Yeah, okay. Uh, so 1 to 3 is the compression, guys, and 2 to 3 is 2 to 3 is a condensation. There the condensation happens. What happens is after the refrigerant is passed from the compressor, it is converted into high temperature, high pressure, superheated vapor refrigerant. Okay. So from there it goes to the condenser. What happens in condenser, guys? Actually in condenser the heat rejection takes place. How the heat rejection takes place in the condenser? You guys can see here again. This graph shows. Uh, can you guys see that parabolic diagram, which I have marked as a saturation dome there? Okay. So the refrigeration, the process which is lying in between that dome is considered as a saturation. The refrigerant is saturated at that point. Okay. So when the refrigerant has passed from the compressor, it is vaporized gas. It is in the form of vapor, and when it enters into the condenser, the pressure is same, high pressure, and it is there slightly low temperature. Okay. So why there is a slightly low temperature, guys? How the temperature is getting dropped there? Why the temperature is getting dropped there? You can see it in the graph there. It
Because
is clearly
the
visible.
superheated vapor is phase changed into saturated vapor. That's why the temperature is
Yes,
slightly dropped.
yes, correct. So the superheated vapor is converted into the saturated vapor. You guys can see that I have marked it as 2 dash. Okay. So the 2 dash is representing saturated vapor refrigerant. Okay. What do you mean by saturated vapor refrigerant, guys? It is before entering into condenser only. Before entering into condenser only, the temperature is getting dropped. Not after getting into the condenser. Before getting into the condenser only, the temperature is getting dropped. And the pressure is same. High pressure. And slightly low temperature. Slightly low. Not tremendous drop is there. There is a slightly drop in the temperature. So as you guys can see here in the 2 dash. Okay. So that is saturated vapor refrigerant. What do you mean by saturated vapor refrigerant, guys? Anyone? Hello. Am I audible, guys? Please speak up. I'm not getting if I'm audible or not.
Yeah, bro. Tell me.
Yeah. So are you understanding what I'm saying? Up to this, have you understood what I said?
Yes, bro.
Yes,
Yes,
yes.
bro.
Yeah. Is there anyone who has not understood and who wants me to repeat?
Yeah, we got it. We got it.
Yeah. Okay. So here in this graph, I have marked something else. Like I have marked slash lines, I have marked with dotted points, and I have given some shades to the particular points. Okay. So I have given its abbreviation there with diagram. So this slash line represent that in that region, the refrigerant is in the form of vapor. Okay. Where there is slash line, at that particular region, the refrigerant is in the form of vapor. Okay. The region where I have marked it with the dotted points, there the refrigerant is in the form of mixture. That is vapor plus liquid. Okay. That is the saturation point. I have marked that saturation dome there. That is the saturation point. After entering into the condenser, the refrigeration gets converted into vapor and liquid. That is the mixture. Okay. Are you getting it? Yeah. Okay. So that is a mixture in the condenser now, which is high pressure and slightly low temperature. Okay. After exiting the condenser, the refrigerant moves to dryer. Okay. So after exiting the condenser, that is the point 3. That is saturated liquid, guys. After exit, yeah,
So I have one question.
yeah, okay,
Uh, in condenser, the refrigerant is liquid refrigerant, yeah?
yeah, right.
100% liquid refrigerant. Am I right?
Sorry, actually, I'm not getting your question. Can you please type it?
In condenser, what is the state of the refrigerant? Liquid or vapor refrigerant in condenser?
Where?
In condenser,
Okay, in condenser. Okay, it is saturated vapor condition, guys. What do you mean by saturated vapor? It is the mixture of vapor and liquid. Okay, there is both liquid and vapor because there is a slightly drop in the temperature, right? As you can see here in the graph, 2 dash, that is saturated vapor. Okay. When entering into the condenser, saturated vapor means maximum amount of vapor is there, slight amount of liquid is there, as there is a slight drop in temperature. Okay. So after entering into the condenser, it falls into the saturation zone, where it is a mixed, completely mixed. It is half vapor and half liquid. Okay, inside condenser because it is falling into saturation zone. Okay. Uh, can you guys please refer the graph when I am saying? Please refer it. You will get it very clearly. Okay. So the point two dash refers saturated vapor. That is before entering into condenser. After entering into condenser, it converts into saturated liquid. Okay. Hope you got it now.
yes, yes.
Yeah. Is there any doubt, guys, up till this, or if I am going fast, or are you like not understanding? Okay. So everyone understanding, right? Okay. So, what happens is at point three, point three is the exit of condenser. Okay. So now the mixture of high pressure and slightly low temperature refrigerant enters into dryer. Okay. What happens in dryer, guys? Any idea?
Moisture
It's
absorption.
remove the moisture content.
Yeah, okay. It removes moisture content because in dryer there is a silica gel. Okay, silica gel is used to remove the moisture content of the refrigerant. Okay, so just a second. Yeah. So what happens, guys, if there is a moisture content inside the refrigerant? What happens if there is a moisture? Anybody? Okay, I will tell it. So suppose if there is a moisture content in the refrigerant, how do we get to know it if there is a moisture in refrigerant? So basically, if there is a moisture in refrigerant, defrosting happens at evaporator point. What do you mean by defrosting, guys? Anybody? I hope you all guys have used refrigerant or refrigeration in your house. Refrigerators are there na, in your house. So yeah, Shubham, you have raised your hand. You want to ask something?
Oh, yeah, I think it's the layer of the ice, it's
Yeah, yeah,
like actually that is a defrost maybe.
yeah, yeah. Actually, the formation of layer of ice is frosting because there is a formation of ice there. Okay, that means the cooling effect is happening. What happens in defrosting? Defrosting is the process where there is no layer of formation of ice. Okay, so this happens because of moisture content present in the refrigeration. Okay, how do you come to know that moisture is present inside the refrigerant? This is the indication. At the evaporator coil, the ice is not forming any layers. There is completely defrosting, and cooling effect is completely reduced. Because if there is a moisture, it forms a insulation layer inside the refrigeration. Okay, that insulation layer prevents the heat transfer, and as the result, there is a defrosting, and cooling effect is reduced. This is how we come to know that there is a moisture content in refrigerant. Okay. Is this clear, guys? Why? How do you come to know about moisture content? Everybody? Okay. So next, in the dryer, the high pressure and slightly low temperature refrigerant is passed. Okay. After passing from the dryer, that is at point 4. Okay. You guys can see in first graph that is fourth point. Okay. In fourth point, after passing from the dryer, the refrigerant is entered into thermostatic expansion valve. Okay. So what is thermostatic expansion valve, guys? Any idea?
It increase the flow and reduce the pressure.
Okay, it increase the flow and reduce the pressure. So to be precise and in technical terms, anyone who can explain it correctly? What is the function of thermostatic expansion valve, or how does it work?
In thermostatic expansion valve, the high pressure and high temperature liquid refrigerant enter and expand air by the
Hmm.
throttling process through the expansion valve,
Okay.
and it converted into the low pressure and low temperature liquid plus vapor refrigerant.
Okay. So basically, guys, what happens here is thermostatic expansion valve is a throttling device. Okay, which is connected through sensing bulb via capillary tube. Okay, so uh, thermostatic expansion valve acts as an orifice. Thus. I hope. What do you mean by orifice? Actually, in orifice, there is a sudden drop of temperature and pressure because there is an increase in area or increase in volume. There is sudden increase in volume. That's why the high pressure refrigerant is converted into low pressure refrigerant because as the area increases, the pressure decreases. Right. Am I right?
Yeah, bro.
Yeah. So as the pressure, as the area increases, the pressure decreases. That's why, as a result, there is a sudden drop in pressure. There is a sudden drop in temperature as well, because temperature and pressure is directly proportional. Okay. Yeah, Raviraj, you want to ask something?
So, sir, when in condition of centrifugal pump, where area increasing, our pressure is increasing, and here area increasing, pressure is decreasing. It's not clear. Can you explain?
Sorry. When area is increasing,
Uh-huh.
velocity is decreasing there,
Yes, velocity is decreasing.
because that is
Right.
fluid, right? This is
Yes.
refrigerant.
Yes.
Are you clear?
Yes, sir, I'm clear, but you just say here area increasing, pressure is decreasing.
Yeah, obviously, because there is a sudden increase in area. There is gradually increasing area, and in volute casing, in case of volute casing,
Okay,
as
okay,
you have
okay.
seen there, that is
Got
a
it.
radially increasing. That is not suddenly increasing.
Okay.
Yeah, here it is suddenly increasing area. So that's why there is sudden drop in pressure. Due to sudden drop in pressure, there is a sudden drop in temperature as well. Okay. So is this clear, guys? Up till this, is this clear? Okay. As there is a sudden drop in temperature and pressure in throttling, that is the thermostatic expansion valve. So here you can see point 4. Okay, point 4, at point 4 you can see that temperature has dropped from T2 to T1. Okay, that means there is a sudden drop in temperature from T2 to T1. Okay, guys, in this graph I have marked that T2 to T1 as a dotted line. Can anybody say why have I marked it in a dotted line? Anybody? Okay. So actually, the process from T2 to T1, that is 3 to 4, is a reversible process, guys. Highly reversible process. That's why I have marked it from the dotted line. Okay. Hope you got it till now.
Adiabatic, right?
Sorry.
Hello.
Yeah.
Yeah, it's adiabatic, na?
Yeah. It's a highly reversible process actually. So that's why I have marked it with the dotted line. So as you guys can see there, there is a sudden drop in temperature from T2 to T1. Okay. In the graph, you can see there is a sudden drop in temperature. That is thermostatic expansion valve. Okay. So as there is sudden drop in temperature and pressure, now the high pressure and slightly low temperature vapor refrigerant is converted into the mixture of vapor and liquid refrigerant. Okay. So here the mixture is in the ratio of 80 to 20 guys. That is 80% is liquid and 20% is vapor. Okay. So now this 80% liquid and 20% vapor, low pressure and low temperature mixture of refrigerant is passed into the evaporator coil. Okay. So evaporator coil, this is the component where the actual refrigeration effect is taking place. Okay. So can anybody explain how the refrigeration effect is taking place in the evaporator coil?
By atmospheric heat, it takes the heat and evaporate
Yeah. Okay.
while at surroundings.
Yeah, correct. It is absorbing the heat from the atmosphere or from the surrounding or from the meat room or something. In case of marine refrigeration system, it is absorbing the heat from the surrounding, right?
Basically heat
Yeah,
exchange, right?
yeah, correct. Heat exchange. So, yeah, Raviraj, you want to ask something? Raviraj, you had raised your hand.
In evaporator coil,
Yeah,
if
okay.
I have one question. In evaporator coil, the refrigerant absorb heat from the surrounding, and the refrigerant effect is produced, or
Yeah,
uh, he, or he or refrigerant absorb heat or latent heat.
sorry.
In evaporator coil, the refrigerant absorb heat or latent heat from the surrounding.
Absorbing heat or lighting? I am not getting
Latent,
this.
latent heat, latent heat,
Latent heat,
latent heat.
latent. Latent.
Latent heat, okay. So actually what happens here is in evaporator coil, guys. 20% is vapor, okay, and 80% is liquid, guys. So here the state of refrigerant is low pressure and low temperature, okay. So low temperature and low pressure refrigerant when it enters into evaporator coil. So you guys can refer the diagram. Just a second, I will share the diagram. You can understand it clearly. Yeah, is it visible, guys?
Yes.
Is this yeah? In this evaporator coil, you guys can see here there is a pattern like coil. Curves are there, right? So when the liquid is passing from here to here, the atmospheric heat is absorbed by the liquid. Okay, so atmospheric heat is gradually absorbed by the liquid, and that liquid gets superheated because that is absorbing heat from the surrounding. Okay, and as the liquid is absorbing the heat, the liquid is converted into the vapor. So here it so while entering here, it is 20% vapor and 80% liquid. So when it comes here, it is 30% vapor and 70% liquid. Slowly, it converts into 100% vapor rise by absorbing the surrounding heat. Okay. So many have raised your hands. Yeah. Gaurav, what's your doubt? What was something?
Yeah, I want to ask you that if someone asks about what is the function of expansion valve, so in short words, we can simply say that to supply proper amount of refrigerant. Is
Yeah.
it right or
I-
wrong?
Yeah, actually, it's right to supply the proper amount of refrigerant by sensing, where the sensing bulb is
Sensing
sensing.
by with the help of sensing bulb, yeah, है ना?
Yeah, with the help of sensing bulb to via capillary tube, right? That is also one of the function of thermostatic expansion valve. But whereas the main function of thermostatic expansion valve is to reduce the temperature and pressure of the liquid refrigerant. It is
Okay,
acting as an orifice there.
okay.
Yeah. Actually, it has many functions. It is acting as an orifice. It is acting as an valve or regulator of the refrigerant. Okay. It is regulating the amount of flow of the refrigerant.
So we can use this at additional point in that
Yeah.
particular.
Yeah. So previously, do you remember I have explained about the moisture content in the refrigerant? The moisture is removed in the dryer. Okay. So supposedly, in very rare case, if the moisture is not removed and the moisture content is present inside the refrigerant, so sensing bulb senses the moisture content in the refrigerant, guys. That is the main function of refrigerant. Sensing bulb, Sanju, I will get back to you soon. First, listen, okay? I will get back to you. I will ask you a question. Uh, so the sensing bulb senses the moisture content in the refrigerant, okay? So if there is moisture in refrigerant, sensing bulb sends the signal to thermostatic expansion valve. Then thermostatic expansion valve reduces the flow of refrigerant, okay? Because there is no proper heat absorption taking place in the evaporator coil. That's why there is a moisture content, okay? Because while entering into compressor, the refrigerant should be completely in the vapor form. Okay. If there is a bit amount of moisture inside the compressor, what happens, guys? What happens if there is a moisture inside refrigerant while entering into the compressor?
The compressor will damage because water is incompressible. Right.
Yeah, correct.
Life will decrease,
Yeah,
basically.
and,
correct.
and
Correct. Uh,
refrigeration stops.
yeah, correct. Actually, water is incompressible, right? And compressor gets damaged. And if compressor gets damaged, slowly, whole the VCRS cycle is getting damaged. That's why, to prevent this damage, there is a sensing bulb. The sensing bulb is sensing the moisture content inside the refrigerant. If there is a moisture content inside refrigerant, what it does is it sends the signal via capillary to thermostatic expansion valve. Then thermostatic expansion valve regulates the flow of refrigerant and reduces it. It will send smaller amount as compared to the previous. Okay. Now, when there is a smaller amount of refrigerant passing through the evaporator, here the complete heat absorption is taking place and all the refrigerant is converted into the vapor form. Okay. Hope your doubt is clear now. Guys, please
Yes,
reply.
yes.
Yeah. Is
Vishnu,
there any
please,
doubt up till
Vishnu,
this?
Vishnu,
Yeah,
please
Vishnu.
ask your question.
Yeah,
Yes,
yeah,
yes.
I have only one doubt, bro.
Yeah, yeah,
You
please go.
told that in thermostatic expansion valve, there is 20% vapor and 80% liquid, right? How it's possible before the evaporator process
No,
is
no, no, no.
attained?
Listen, listen, listen. Actually, in thermostatic expansion, it is not inside. It is after passing from the thermostatic expansion valve. Okay, because
Yeah,
thermostatic
yeah.
expansion valve is working as an orifice there. Because there is a sudden drop of temperature and pressure because of increase in area. Okay, so here, as there is a sudden drop of temperature and pressure. Now, look, after passing from the dryer, the refrigerant is in the form of vapor. Okay, it is in the form of high pressure and slightly low temperature. Okay, high pressure and slightly low temperature vapor refrigerant when it enters into thermostatic expansion valve. Now, just look at the simple example, guys. When the vapor is cooled, what happens, guys? When the water vapors are cooled, what happens? The water vapor condenses and forms the liquid, right? Am I right or wrong?
Yeah,
Right.
yeah.
Right. So, similar process is happening here also. So, when there is a sudden drop in temperature and pressure in a vapor refrigerant, 80% of vapor refrigerant is converted into liquid that is cooled down up to 8 to 5 degrees Celsius, 5 to 8 degrees Celsius. Okay. At 5 to 8 degrees Celsius, it is cooled down and 20% vapor is still there because it was superheated. 100% of vapor is not converted into liquid. Only 80% of vapor is converted into liquid and 20% of vapor is still in the form of vapor. But there is a drop in temperature. Okay. So now when it passes through the evaporator, vapor is in the form of vapor only. Now the liquid is absorbing the heat, guys, because liquid is having the low temperature. It is absorbing the heat and giving back the cold. Okay. So here the heat exchange is taking place in the evaporator coil. Now, as the liquid is absorbing the heat, again it is converted into the form of vapor because liquid gets heated because it is absorbing heat. Okay. So now it gets heated and it is converted into vapor. So slowly, when they look at this diagram I am marking here. So when the liquid pass slowly through this coil, here it is 20% vapor, 80% liquid, right? When it comes here, it is 70% liquid and 30% vapor. When it comes here, it is 40% liquid and 60% vapor. And when it comes here, it is 50% vapor, 50% liquid. When it comes here, it is 60% vapor and 40% liquid. So similarly, when it comes to end, it is 100% vapor, guys, because it is continuously absorbing heat from the surrounding. Are you getting, guys?
Yeah, bro, yeah, bro.
Yeah, Shubham, is there any doubt?
Yeah, as you told, before entering the evaporator coil, there are 80% of liquid and the 20% of vapor, right?
Yeah, correct.
Yeah, but after entering into the evaporator, the heat will exchange, right? And
Yes,
the
correct.
phase will change. But
Yes, correct.
so what happened with the remaining that 20% of vapor, like that superheated?
Look, yeah, that vapor is going through the evaporator only. Okay, that is again superheating because that is
Yeah.
also absorbing the heat. Okay,
Okay. Yeah.
vapor is also absorbing heat because now
Actually,
the
yeah.
temperature of vapor is less. Okay, due to
Yes.
the sudden drop of temperature in thermostatic expansion valve, now the temperature
O-
of the vapor is less.
Okay.
Now, as
Okay.
it is moving into evaporator, that is also absorbing heat.
Yeah. Yeah. Yeah.
Now the vapor is converted into superheated vapor.
Yes. Yeah.
Yeah, as well as liquid is converted into vapor, and as it gradually moves through the evaporator, that normal vapor is getting into superheated vapor.
Okay.
That is absorbing heat. Nice.
Yes. Yes.
Yeah. Now the liquid is converted into 100% vapor. Now that 100% vapor is again passed to the compressor. Okay. So this is the cycle of vapor compression refrigeration. Okay. So this is how it works. So these are the four stages, guys. In first stage, as I said, in compressor, that is isentropic compression happens. Isentropic compression in the sense compression effect is happening there. Look at the graph. Now let us go back to the graph. Just a second. I will share the. Yeah. Is this graph visible, guys?
Yes.
Yeah. Okay. So from 1 to 2, I have marked there. The slash line represent it is in the vapor form. Okay. The dotted line represent it is in the mixture form, and the shaded line represent that it is in the liquid form. Okay. So again, let's come back to this graph. 1 to 2 is the compression. That is now the vapor has entered into the compressor. Okay. When the vapor has entered into the compressor, you guys can see at 1 there is a temperature is less and pressure is also less. Simultaneously look at this also, guys. Simultaneously look at the second graph also. Here the 1 is at the P1. Okay. That is pressure is minimum, less pressure. And here the 1 is at T1. That is temperature is also less. After entering into the compressor, the temperature is increasing, guys. You can look here. 1 to 2. The temperature is increasing. And as well the pressure is increasing, guys. Are you following it?
Yes.
Yeah. The temperature and pressure is increasing. And that's how the cycle repeats. So I hope you are clear with the cycle now. Basic concept. This is the working process of the VCRS. So later on we will discuss about what is the temperature at particular place. Exactly what is the temperature, what is the pressure. Actually, that depends on the type of refrigerant, guys. The type of refrigerant we are using. So when the interviewer asks what is the pressure and temperature at evaporator coil, you are not supposed to directly say that this XYZ is the temperature and pressure at the evaporator coil. No, actually, it depends on the type of refrigerant you are using because there are different properties for different refrigerant, right?
Yeah, right.
Yeah. That's why first you need to mention a most commonly used refrigerant that is R134A or tetrafluoroethane. So after mentioning that refrigerant, you have to mention that this is the approximate temperature and pressure of refrigerant at this particular point. Okay. Okay. So hope up till this it is clear. So, guys, have you understood the graph or is there any doubt in the graph? Have you all of you understood the graph, right? Both the graphs, like where there is compression, where there is heat rejection. Actually, in condenser, the heat rejection takes place, guys. As you guys can see here, from 2 to 2 dash, there is a slightly drop in temperature, right? From 2 to 2 dash, there is a slightly drop in temperature. Are you guys following it? Yeah. Who has raised this hand? Okay. No. So up till this, it's clear, right?
Yeah, the saturated vapor point, right?
Yeah. So is there any doubt in this graph, guys? Do you want to ask something about today's session? Actually, this was the introductory section of VCRS. Okay. So we will
Yeah, can you
discuss in
can you
depth.
revise can you revise shortly, please?
Yeah, 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 sure, sure. Okay. So you want to revise about the working process, right?
Yeah, it's like the whole cycle.
Yeah. Okay. Whole
Working
set.
cycle.
Yeah. So what happens is basically, guys, the low temperature and low pressure vapor refrigerant enters into the compressor. Okay. Just let me show you the diagram and explain. It will be easy. Yeah.
Yeah.
So yeah, is this diagram visible, guys?
Yes.
Yeah. Okay. So the low temperature and low pressure vapor refrigerant is entering into the compressor. Okay. Here, what is happening, guys? The compressor is compressing the vapor refrigerant. Okay. After compressing, now the low temperature and low pressure liquid refrigerant is converted into high pressure, high temperature superheated refrigerant, superheated vapor refrigerant. Okay. Because it is compressed. So after compressing, the high temperature and high pressure vapor refrigerant is entering into the condenser. Here in condenser, there is a heat rejection taking place. Heat rejection in the sense the pressure is constant, but the temperature is slightly dropping here. Okay, the slight temperature drop is happening here. That's why it is said as high pressure and slightly low temperature vapor refrigerant is passed into the condenser. Okay, after heat rejection, the high pressure and slightly low temperature vapor refrigerant is passed through the dryer, where the moisture content in the refrigerant is removed. Okay. After this, the state of refrigerant is still high pressure, superheated, and slightly low temperature, even after passing from the dryer. Okay. So now this high pressure and slightly low temperature vapor refrigerant is passed into the thermostatic expansion valve. So basically, what is the function of thermostatic expansion valve, guys? Thermostatic expansion valve is a throttling device. It acts as an orifice where there is a sudden drop in temperature and pressure of vapor refrigerant. Okay, because there is a gradually increase in area, so a sudden increase in area. That's why there is sudden drop in pressure and sudden drop in temperature. Okay, so now the superheated high pressure, slightly low temperature vapor refrigerant is converted into low pressure, low temperature liquid and vapor mixture of uh, refrigerant. Okay, it is converted into mixture. The mixture is 80% liquid and 20% vapor. Okay, so I have explained why 20% and why 80%. Okay. Hope you guys know it. Or should I repeat it?
No, no, continue.
Yeah, okay. So after this low pressure, low
Repeat.
temperature, okay, so I should repeat. Okay. So why this happens is as there is gradual increase in area, there is a sudden drop in pressure and temperature. Now, guys, see, when there is sudden drop in temperature and pressure of a vapor, the vapor gets converted into liquid. Okay, this is a simple example, guys. This is you can observe in day-to-day life. Okay, when the vapor is condensed to the lower temperature, it gets converted into liquid. Similar, that process is happening here also. Okay, so the vapor refrigerant is now converted into 80% of liquid and 20% of vapor. That is low temperature and low pressure. Okay,
Yeah.
now this
Hello.
low temperature, yeah,
Yeah, so basically the phase change, right? In the
yeah,
that
yeah. The phase is changing here. As the phase changes, the temperature and pressure drop is taking place inside the refrigerant. That's why it is converting into 80% liquid and 20% vapor. Now, this 80% liquid and 20% vapor is entering into the evaporator coil. Okay. So, now this is the final stage, guys. Here, the actual heat absorption is taking place. You guys can see there is a fan connected in front of evaporator coil, which is absorbing the heat from the surrounding. Okay. This heat is absorbed by vapor and liquid both. Now, this vapor refrigerant, when it is absorbing heat, it is converted into superheated vapor. Okay. As well as the liquid, when it is absorbing heat, it is converting into vapor. And gradually, just a second, yeah. And gradually, when the vapor is passing through the evaporator coil, it gets converted into 100% vapor. Okay. So this 100% vapor is now again passed into the compressor. Okay. So this is the cycle of VCRS guys. So up till this, is there any doubt? Hello, guys, is there any doubt? Please speak up.
No, no.
No, no, no.
No, no.
It's clear, bro.
Yeah. So you have understood the graph, you have understood the VCRS components, and you have understood the working of VCRS, right? So that's it for today, guys. So we will continue about this in depth from tomorrow. Like what is the exact temperature and what is the exact pressure at particular location. Okay. So after this, there is no doubt, right? Yeah, okay. So we'll continue this tomorrow. Shall we wind up or do you want to ask something? Anybody?
No,
No,
no, bro, it's perfectly clear.
Yeah, okay. So I will share all these slides which I am sharing. I will share it into the group now. Okay. So you
okay,
guys
buddy.
can refer those notes.
Okay, buddy.
Yeah, okay.
Thank you so
Uh,
much, bro.
yeah, sure, sure. So shall we wind up?
Yeah, yeah, sure.
Yes, yes.
Yeah, yeah.
Okay. Bye guys. Take care. Let's meet tomorrow.
Same to you.
Yeah. Welcome.